Now we'll discuss the question number 49, and it is from Taylor tool life equation. And the question is, Taylor's tool life equation is used to estimate the life of a batch of identical high-speed steel twist drill by drilling the through hole at constant feed of 20 mm thick mild steel plates. Now in test 1, a drill lasted 300 holes at 150 rpm, while in test 2, another drill lasted 200 holes at 300 rpm. Now the maximum number of holes that can be made by another drill from the above batch at 200 rpm is. So we have to find out that number of holes which is to be drilled at 200 rpm. Now we'll see how will we find out that. Now we know that time to drill a hole, which is equal to that length of that tool travel upon this feed into n. This is the machining time to drill a single hole. Now in the first case we have to drill a 300 holes at 150 rpm. So that time, that tool life, which will be equal to that number of holes, which is 300 multiplied by that length of that tool travel upon this feed into n is 150 rpm. So it is 150, which is your n1. So for n1, this is t1, that is for first case, for test 1. Now for test 2, this t2, that is your tool life, which is equal to that. In the test 2, we have to drill a 200 holes. So 200 multiplied by that length of this tool travel upon feed into that n, which is 300. Now the maximum number of holes that we have to find out in the third case. So for t3, we have to find out this number of holes, which I have assumed it is y multiplied by L upon this feed into at this 200 rpm, 200. Now from Taylor tool life equation, we know that V1 T1 to the power n, which is equal to V2 T2 to the power n, which is equal to V3 T3 to the power n. And we know this V is directly proportional to that n. So I can write N1 T1 to the power n, which is equal to N2 T2 to the power n. Now N1 upon N2, which is equal to T2 upon T1 to the power n. Now in the first case, N1 is 150 and N2 is 300. So I can write 150 upon this 300, which is equal to T2, we have 200 into L upon F into 300. So I will write 200 L upon F into 300, and T1 is 300 L upon F into 150. So directly I write F into 150 upon this 300 L to the power n. Now this is 1 by 2, this 150, 2, so it will be 100. So this 1 by 2, which is equal to 1 upon 3 to the power n. So if you will solve this, you will get, so what I will do is ln 0.5 will take ln, so which is equal to n ln 1 by 3. So if you solve this, you will get n equal to 0.63. This is the value of n, which is equal to 0.63. Now we have to find out the y. We have to find out the value of y. That is the number of holes at 200 rpm. So what I will do is I will write n1 t1 to the power n, which is equal to n3 t3 to the power n. So n1 we know it is 150. So 150 multiplied by t1, we have this 300 300L upon F into 150, which is equal to N3. N3 we know 200. So 200 into T3 we have Y into L upon F into this 200. So I can write this 150 upon 200, which is equal to YL upon F into 200 multiply by F into 150 upon 300 L. To the power n, we know it is 0.63. Now if you will solve this, you will get y equal to this 253.36, which is equal to 254, I can say. So the answer will be 253.36. That was the number of holes at that 200 RPM.